In the 1970s, a simple household appliance became the center of a brutal corporate war. The victor conquered the market using a calculated, aggressive legal strategy. At the time, vacuum cleaners relied on a deeply flawed piece of engineering. They collected dirt inside a porous paper or canvas bag. As the machine ran, fine dust particles would rapidly clog the tiny pores of that bag, suffocating the airflow and causing a steady, frustrating drop in suction power. This flaw was highly lucrative. Manufacturers operated on the razor and blades business model. They sold the actual vacuum at a relatively low price to lock consumers into buying high-margin, disposable replacement bags for the lifespan of the machine. For the dominant appliance companies, that declining suction was a guaranteed revenue stream. Fixing it meant killing their own profits, which meant a solution would have to come from a complete outsider. That outsider was James Dyson. Frustrated by his own failing vacuum, he spent 5 years in a backyard shed, building exactly 5,127 prototypes to eliminate the bag entirely. His eventual breakthrough relied on cyclone technology. Instead of pulling air through a physical filter, this design forces dirty air into a rapid circular vortex. The centrifugal force throws the heavy dirt outward and down into a bin, while the clean air escapes through the center. By removing the physical barrier of a bag, Dyson removed the clogging variable. This graph compares suction performance over time, showing how the suction power of a bagless machine forms a flat horizontal line, remaining perfectly constant from the first use to the 100th. A machine that required no replacement parts posed an existential threat to the established industry. Dyson knew that the moment he proved a bagless vacuum could work, billion-dollar corporations would immediately copy the design to protect their market share. Engineering a spinning vortex solved the physical problem of cleaning a rug. Surviving the inevitable corporate retaliation required a totally different kind of architecture: intellectual property. Dyson's defense began with a foundational filing, the patent for a cyclone separation apparatus. This single document legally defined the core mechanism of spinning air to remove household dust, serving as the anchor for his entire product line. Because a single patent is vulnerable, Dyson deployed a fortress strategy. His legal team surrounded that central concept with hundreds of secondary incremental patents. They filed claims on everything from the specific geometry of the motor housing to the exact mechanics of the ball steering joint. This layered defense creates a legal minefield. Even if a rival company manages to engineer a workaround for the primary cyclone patent, they are blocked at the perimeter by the sheer density of ownership over all the practical, commercially viable ways to build the rest of the machine. These layered filings legally fenced off an entire technological field of fluid dynamics and consumer appliance design for decades. When Dyson captured massive success, traditional giants like Hoover developed their own bagless models, placing them side by side on store shelves to siphon off consumer demand. Dyson immediately took Hoover to court, arguing that their new triple vortex design directly infringed on his dual cyclone patents. The court agreed, forcing Hoover to pay millions of pounds in a massive settlement and validating Dyson's legal moat. However, the fortress isn't completely impenetrable. When Dyson sued Samsung over the design of a steering mechanism, Samsung's lawyers successfully presented prior art, which is any existing evidence that an invention is already known, invalidating a new patent claim. Facing this evidence, Dyson was forced to drop the litigation. A similar scenario played out in a grueling 4-year legal battle against the appliance maker SharkNinja. Dyson alleged infringement on specific cyclone technology, but ultimately lost the case in United States courts. Securing a patent does not guarantee a courtroom victory. What it does guarantee is a seat at the table. Without those filings, Dyson would have had zero legal leverage to force those billion-dollar competitors into a courtroom in the first place. By aggressively defending its technology, Dyson forced a permanent macroeconomic shift in the appliance market. The old reliance on selling cheap vacuums supplemented by high-frequency bag sales was abruptly broken. This chart compares the 10-year total cost of ownership between the two models. Dyson convinced consumers to pay a single, massive upfront price for high-end engineering. Buyers accepted the premium because it permanently eliminated their dependency on purchasing replacement parts year after year. Stripped of their recurring bag revenue, the rest of the global industry had no choice but to follow suit. Competitors had to pivot toward developing their own premium, bagless hardware simply to remain relevant to consumers. Dyson used the patent law surrounding that spinning vortex to dismantle the industry's archaic, century-old revenue model. Today, that strategy has built an empire, generating over £7 billion in annual revenue, directed from a global headquarters in Singapore. Because Dyson remains a strictly private company, they do not have to answer to public shareholders demanding short-term quarterly dividends. They funnel their enormous profits directly back into long-term research and development. This creates a self-sustaining corporate loop. Intense research generates new patents. Those patents create a temporary market monopoly, and that monopoly generates the premium capital required to fund the next wave of research. For any serious inventor or founder, the lesson is clear. Patent drafting is not administrative paperwork handed off to a lawyer at the end of the design process. Rather, it is an offensive business weapon. A brilliant idea can solve a mechanical problem. To actually capture the value of that idea, you have to engineer the law with the exact same rigor that you engineer the product.